Hi, it's Creative Shrimp here, and you're watching the photogrammetry course with Blender and Reality Capture. In these set of chapters, we're going to lean into the Blender side. Here we'll take our massive amount of scanned polygonal data and squeeze it into Blender. We'll then be able to bake or render out passes that we can then work with and make everything way more manageable. We'll see that as we're working with such massive files, we're going to soon bring Blender to its knees, and it's going to get very choppy in the viewport. Selections are going to be slow, saving will be slow, time will become meaningless, when we'll perhaps be questioning our life choices, but there is a light at the end of the tunnel, because if we link everything into a different blend file, it will be way easier to work with. So let's get to it. So here we're just in a simple default Blender scene with the standard collection of objects. For our FBXs that we're about to add, I'll click on the top scene collection, and then with the cursor still within the outliner, we can add another collection with the C key. Then we can rename it to FBXs. With this collection highlighted, any objects we create or import will find themselves already organized inside this collection. The FBXs that we'll be adding can be found in a folder called ultra_high poly 100 million cleaned up. Inside we'll find all the FBXs that we'll need numbered from 0 to 33. These are the files that Gleb has cleaned up for us from within Reality Capture, removing the shelter that would be otherwise getting in our way. Once we've imported all of these, we'll see there's a hole in the geometry from where the shelter used to be, but that's okay, we'll fix that in the renders later on. Alright, let's get importing these into Blender then. First though, we'll do the sacrificial cube deletion with the X key, and then move up to the file menu, find import, and then choose FBX. I've already navigated to where those FBXs are for me, and then I'll select the first one in the list and press the Import FBX button in the lower right corner. Here is where we're going to start seeing a bit of a limitation of Blender, depending on how powerful your machine is. Mine is a pretty mid-spec machine, so maybe quite representative for the amount of times that I'm going to get here for most people watching this, perhaps. And we've got a lot of files to import here, and as we can see, the first one is taking around 50 seconds or so to import. Navigating around though, everything for now seems quite smooth. Let's just jump over to the shading workspace and take a look at the vertex color detail on this. We haven't got a material on this, so from the material pull down, I'll just select the default material. Then to see our vertex colors, we'll need to go Shift A, Input, Vertex Color to create the node we need. The vertex color set is called Col, which is the only one we'll find in the drop-down. Then we can hook that up to the base color of our principled BSDF shader. And that's all there is to it. We can now see all of those colored vertices in all of their splendor in Blender's viewport. The amount of vertices we've got holding that colored information, all that detail holds up pretty well even if we zoom pretty far in. Something I think is worth adding into this section is that currently we're looking at this with all the bells and whistles of Eevee's rendering engine. That will give us decent lighting and shadows, but that might be overkill at times, and if we find that we're struggling in the viewport, we may need to optimize further. In that case, we can do away with Eevee's better lighting by switching back to solid shading mode, where thanks to some clever trickery with faked lighting using normal direction, we can still get a pretty good result. And we can still get a good view of our vertex colors by switching to vertex in the options. Keep in mind that this is in addition to any lighting trickery, lighting emulation in other words, that we have set. So in this case, that means this studio lighting sphere here. We can change that to something brighter, and it'll look like our scene just got a bit brighter. Or we could switch it to a matte cap and get even more lighting combinations. We can even introduce some ambient occlusion or some simple shadows, though we may find the shadows in particular might start slowing our viewport right back down again. Currently though, I'm just simply going to switch back and continue on for now with our material preview shading. Alright, so by left clicking and dragging from the top left of the 3D view, I'm going to collapse the file browser window there and give this workspace a little more room. And this is the first important Blender file we're creating, so let's play it safe and go up to the file menu and save it using Save As. I'll place this in the main blends folder and call it Scans Master. Pulling out the windows a little here, we can see the full name of the file we've just imported there in the outliner. As it's selected, we can also see it in the top left of the viewport too. To get more details in the viewport about what we're looking at here, we can go to the Viewport Overlays menu and choose Statistics. This shows us that just in this one mesh we've got 2 million vertices and about 4 million faces. It's pretty convenient having this show right here in the viewport, but I also have it turned on down at the bottom of the screen. If we right click this here, we can see some options for extra data to appear in the status bar too. Personally, I prefer to keep them down here and out of the way, so I'll disable the statistics in the viewport overlays. Incidentally, it's worth pointing out that for a 1024 by 1024 texture, we'd need about 1 million vertices to account for the million plus pixels the texture would demand. We've got 2 million here, so we're in good shape. And that's just this one small chunk of the overall scene. For a 2048 by 2048 texture though, we'll need upwards of 4 million vertices. And for 4096, we're going to need upwards of 16 million. This whole scene will be about 100 million vertices overall, so for most areas we want to capture and convert to texture, we can see that the density of what we have should be well enough. Alright, so we're on the right track. Let's start importing some FBXs. We don't need to do them one at a time. Here I'm going to try importing the next 3 files by selecting the first one and then shift selecting the last of the 3 I want, just for the moment. Then, as we did before, I'll select Import FBX. This is about twice as much data as we imported before, so it should take about twice as long. And fast forwarding here, we can see it took about 2 minutes, which sounds about right. Rotating around the view, we can see the additional meshes we've imported in. They're not in any particular order, that is to say they're not exactly all sat right next to each other, but that's okay. We'll eventually have the whole jigsaw, so to speak, eventually. The new meshes don't have the correct material. There's a few ways to copy this across. One way is to make sure the mesh without the material is selected, and then shift select the mesh with the correct material on, so we can press Ctrl L to link the materials. Now both of those meshes share the same material. We can do multiple meshes at a time here, so I'll select the others, making sure to select the mesh with the correct material on last. And again, pressing Ctrl L, we can link the material so that all our meshes now share the same material. We're at close to 13 million faces, and the viewport still moves pretty fluidly. Saving the file doesn't take too long either, but we'll see as the poly count skyrockets, so does the saving time and the general performance. Here I've skipped ahead and imported the rest of the meshes in, which as we can see here took around 26.5 minutes. At this point we're going to need to find a workaround from having to use this particular blend file here. As we can see, it's going to be a massive pain to navigate around as it's now super choppy. Also, let's break out the timer again and see how long it takes to save. Alright, so that's over 2.5 minutes. Even simply selecting is going to be arduous. Here I've just selected a mesh towards the right side and it's actually about 45 seconds before it gets selected. As I say, this scene will be a nightmare to work in. Before we say goodbye to this scene though, I'm going to give all these meshes the correct material, so I'll press Shift G and then choose to select everything in the same collection as the mesh we've already got selected. Everything's selected fairly painlessly there as we're not clicking directly in the viewport. Then we can press Ctrl L and select to link our material to all of these meshes. This linking material operation is something else that's going to take about another minute or so to copy across. This all means basically it's going to be very unworkable to work in this blend file, especially if we check our preferences from the edit menu and take a look at the autosave. That's set to by default to 2 minutes. Our file takes more than 2 minutes to save, so we really have to fly without a safety net and disable that for the moment and remember to turn it back on later. But here at least we have now imported everything, almost 100 million polygons of scanned data. At this point we're finished with this file, but before I save it one last time, I'm going to switch over to the layout workspace where we're in a larger solid shading view. The frame rate of the viewport is still very choppy even without displaying the vertex colors, but I'm hoping leaving the file in the solid shading view will help the file load up just a little bit quicker if we were ever to need to open this file up again. So with that, I'll save it again and jump into a super snappy new blend file and feel that fresh wind beneath our viewport wings once more, instead of some kind of molasses swamp that we were in before. And here's where we're going to link in the objects from the scans master file. First in the viewport, I like to click on the filter menu there to see a few more options, such as whether we want to disable the object in the view and also its selectability. With those new options, it means I can disable the cube in the viewport. That is to say, not just hide it, but to completely disable it. We will be using the cube a little later, but for now, we can disable it so it doesn't get in the way. Also, we won't be needing to render this cube, so I'll turn that option off in the outliner as well. As we did before, I'll select the root collection and press C with the cursor still in the outliner to create another collection. I'll call this Facade Linked. There's two main sides or facades of the overall building that we'll be working with, and we'll link them all into this collection. First, let's save, so we'll go File, Save As, and then in the main Blends folder, I'll place this file here with the other one and call it Scans Master Linked. Then it's time to get linking, so we'll go File, and then Link, and then double click on the Scans Master file, click into the Objects folder within that blend file, and there we'll see all the imported FBXs. I'll just link the first one for now, so I'll highlight it and then press the link button in the bottom right. As you can see, that was almost instant, a far cry from the 50 seconds it took to import the FBX. Let's try linking in the next 5 or so objects. It takes just a few seconds, not a few minutes, thankfully. So we can see the names a little better. I'll make the outliner window a little wider there. Next, I'll link in the rest of the objects. It'll take a little longer, but for me, it only took about 30 seconds. Again, much better than the 20 plus minutes we were getting with importing the FBXs. While the viewport isn't super smooth, it is improved from before and definitely workable. Selecting between the objects is much faster, and if we go up to File and Save, we can see that's less than a second. Going back over to the File menu and selecting Save As, so that we can see the two files, we can see why this file is so much faster to save. It's currently not even 1 megabyte, whereas the Scans Master is close to 7 gigabytes. This is because the original data will be kept and held within that larger file. This is great for working in teams, for example, where different artists are working on different blend files that get linked into another master file somewhere that contains the full scene. For us, well, we're getting a much lighter file to have to deal with. So because of that, I'm going to head back over to the edit menu and select the preferences and then re-enable autosave, bringing back our safety net, as we don't need to worry about super long saving times anymore. Clicking on the 3 horizontal lines, we should see that by default the changes to our preferences are automatically saved. Or if not for some reason, then this is where we check just to be on the safe side. I'll deselect any selected meshes with Alt-A so that we can get a clear look at this. It should be pretty obvious that there are what looks like lines running between the borders of each mesh. To disable these, we'll find them in the shading menu. To clean the view up even further for the moment, I'll disable the viewport overlays too. I'm not sure why the outlines are separated into the shading menu, but with that done, we can get a very clear look at this. To highlight the next issue, I'll change the background to the viewport instead of the theme, and then set a background color to something super bright. Now we can check for any gaps between the meshes that shouldn't be there. And if we zoom in far enough, we can see that there is actually a very slight issue between some of the meshes in this area. Almost imperceptible, but it's definitely there. This is due to a reality capture bug that reality capture are aware of, and hopefully it's resolved by the time you're watching this. It has something to do with the 100 million vertex count, we think. If you use less than this or more than this, then the bug seems to go away. But in the interest of learning how to work around this sort of stuff, we'll keep it in. Alright, here's a little bit of extra useful information regarding linking that I wanted to insert here where it made the most sense with the rest of the subject on linking. Although actually we don't need to do these particular steps until we start rendering from the camera instead of baking. Baking being the subject we'll be exploring a little bit more in the next chapter. Getting right into it, a feature of linking is that we aren't able to actually move our objects around here. They're firmly stuck where they are. And where we might select a material is all grayed out at the top of the shader editor. That's all by design. If we wanted to move something or switch materials, that would need to be done in the original blend file. However, Blender does provide us with a way to override this behavior, and this is what we'll find particularly useful when we come to changing settings within the material later on. I'll start at the bottom of the outliner and work up, so mesh number 33 that looks like. So I'll right click on that and go down to the ID data section and choose Make Library Override. That's all there is to it. We can see now the icon has changed from a chain link icon to having a little arrow icon going through it diagonally. I'll make sure it's selected and then go over to the Material tab in the Properties window. And to get this to work so that Blender will remember that we've assigned a different material to this mesh, even after we've saved and closed Blender and then reopened it again, what we need to do is change from this material being linked to the data to being linked to the object instead. we'll see that then turn to a sort of turquoise colour, showing we've overridden that property, and now we can choose a material from the pull down. The one with the L is the linked material, so I'll use the other material that is local and not being linked in from another blend file. All we need for now is to add an input vertex colors node, and then choose the color set from the pull down menu, and then plug that into the base color of the principled BSDF. And that's about it. I'll also rename the material to material.local so that we can recognize it easily. Now, as we can see, the object can even be moved around, even though the data for that mesh is held in the other blend file, though the material is overridden and is going to be held in this one. Unfortunately, I've not really found an easy way to do this to all of the objects in one go. It's probably something that can be automated within a script, though this overriding process is an area that is in consistent development within Blender, and so I'm thinking that likely very soon, and hopefully even by the time you're watching this, that the process is possible to do all in one go. And if so, we'll include it in the course. For now though, I'll just go one by one through the objects, right-clicking on them in the outliner, and then choosing to make a library override, select it, switch linking the material from data to the object instead, and then choosing the material we want from the pull down. Otherwise that should wrap us up and have us nicely set up and ready to begin on setting up for our first pass, the base color. Previously we managed to override all of our linked meshes, giving us some local control over the objects. That means we're ready to start rendering, or baking for that matter, which is what we'll be looking at here. However, simply due to the order in which I've recorded some of these videos, in this baking chapter we might notice that the objects are not actually overridden here. That's not going to make any difference to us, though, while we're baking, but I figured I'd point it out just in case it caused any confusion or concern that something may have been missed. At this point, we're ready to start baking, except we're actually not going to be using Blender's baking tools for this process. We'll be rendering instead, which is going to take a little bit more setup, but I think you'll find it easier and more efficient in the long run. But we will look at baking within Blender to understand the differences in approach. First, I think it's worth pointing out that the baking process for Blender when compared to other softwares is actually quite basic. This is why there are several add-ons out there on the Blender market, for example, that try to make the process much easier. There is one that we'd like to highlight though, which also happens to be freely available, called Bysted's Blender Baker. That's Bysted, by the way, as in the ever-inspiring Daniel Bysted. If you haven't already checked out his work, it's phenomenal, so we urge you to do so. Daniel's put together a fantastic Blender add-on that gives better feedback while baking, a way to link or pair together objects so that you don't have to manually select the necessary target and source objects each time you bake. And also you can bake several passes in one go and preview each one easily after the bake is complete. That actually just scratches the surface of some of the features too, so it's well worth checking out. And you can find it on Daniel's Gumroad page, which you can see here. Starting off back where we were with the linked master scans file, let's take a look at Blender in its native form with no add-ons and how we might go about baking out some of our scan data to a texture. First of all, let's roll back a few of the changes we did to highlight the gaps between the meshes. So I'll go up to the shading pull-down menu and turn the outlines back on, as we'll give our eyes a rest by switching the background back to the theme color. Next, I'll turn the viewport overlays back on. With a fairly heavy scene to draw in the viewport, this can actually take a few seconds to register. Now that the layout workspace is back how it was, let's jump over to the shading workspace because it's useful to be able to see the shader editor and a window that shows us the texture. Keep in mind that as the viewport has also switched to material preview, the vertex colors might slow us down a little by 10 or 20 seconds or so while they load in. Then I'll give us a bit more room on the top half by placing the cursor at the top left of the 3D view and then left-clicking and dragging towards the left to collapse the 3D view into the file browser. Unfortunately, the viewport is still a little slow to work with while we view all the meshes. However, it will speed up considerably once we temporarily hide the meshes we don't need. I'll just give us a bit more room in the outliner and then press the little down arrow next to the main collection so that we can only see the collection name and not all the objects inside. That gives us a clearer view of the bottom of our outliner. That'll be useful when we create a new collection in a moment. To do that, I'll shift select these brick wall meshes on the front left of the building that I want to include in the bake, and then press M to move them to a new collection called Bake Example. We'll see that then get added to the outliner. Then we can click on the little checkbox for the facade linked collection to exclude all of the other meshes that we don't need right now. Thankfully now the viewport is unleashed and is super smooth and easy to navigate around again. To bake, we're going to need something to bake to, and since we're just going to be creating square textures, all we need is to add a mesh plane. Then we need to move that plane in front of the geometry we're going to bake onto it. I'll press R to rotate, then Y is the axis I need to rotate around, and then type in -90 to align it roughly with those bricks. Then, while using the middle mouse button to rotate the view so that we're nearly looking straight on, I'll hold Alt, and that should snap the viewport to the appropriate orthographic view so that we're looking exactly at it with no perspective distortion. Then I'll scale and move it in front of the section that I'd like to try and bake for this example. The distance that the plane is away from the wall doesn't really matter by default, but I do like to move it a little closer so that it's pretty clear what section we're baking, even if we rotate out of the view and look in perspective mode. This plane doesn't have a material on it yet, so I'm going to use the default one from the pull-down menu. And next we need a texture to bake to, so over in the image editor on the left we'll make a new image called Test Bake, and the 1024 by 1024 as the size is fine, and the rest I'll also leave as default. Zooming out a little bit, we'll be able to see our resulting bake image show up here. To let Blender know that we want to bake onto this image though, we simply need to have this image selected in the shader editor. So clicking on the image icon, we can drag that across, and Blender will create the texture node for us automatically. We don't need to hook it up to anything, we just need to have it selected. Eevee currently doesn't support baking, so we need to switch to cycles, and then we'll get access to this baking panel. These are all the available passes. Unfortunately, we don't have something to capture the height here, but there is an option that we'll come back to on that shortly. For now, I'll choose to bake a normal map which can give us the illusion of height. By default, Blender is not going to bake onto this plane the other geometry around it, rather it'll bake just whatever the current shader is doing, which for us at the moment isn't really a lot. So just to make it more interesting, I'll create a texture, noise texture, and hook the color output to the base color input of the shader. Now since that's a color channel, to see this we'll need to switch our bake pass over to the diffuse bake type, and then we'll be able to just bake the diffuse color pass. This means we'll get our noise texture with no lighting taken into consideration. If we bake now, we get a helpful bit of info at the bottom to tell us that Blender doesn't know what image texture to use to bake to. So once we select that texture node in the shader editor and bake again, we should see our color pass show up in the image window on the left. That took me nearly 2 minutes to bake, which is actually much longer than necessary considering we're not even using any lighting calculations. This is because another consideration is how many samples we're telling Blender to use during the render. I'm going to left click and drag across these both to set them to the same thing. Something really low like 2 should just do for us for now. Another consideration for how fast it bakes is whether we're set to use the CPU or the GPU. Usually the GPU is much faster, but the CPU in my experience tends to be a little more bug-free, so while I'm recording this, I'm going to be choosing CPU, but usually I would select GPU if you have it available. Even on CPU though, with much lower samples, we can bake out a texture of this size at around 5 seconds or so, and that's way shorter than the 2 minutes that we got a moment ago, so I feel that's perfectly reasonable. To bake the geometry behind the plane onto this texture, we need to enable the selected to active checkbox. Then I'll switch back to the normal bake pass. Clicking bake now will warn us that we haven't selected anything to bake to this plane, so since the plane is currently the active object, all we need to do is press A to select everything else in the viewport, and the plane will remain as the active object. So pressing bake again will help us through the bake process by telling us that we actually have a light object selected. That of course isn't a mesh object. Probably Blender should just ignore those object types automatically, but it's simple enough to deselect everything with Alt-A, disable the collection with our objects that we don't want in the bake, and then select our plane and press A again in the viewport to select everything else and then press bake. As we can see, if we bring up the timer, that this is going to be a little more intensive, but still reasonable at 30 seconds or so. The normal map is baked, but It isn't saved yet, so I'll go to the three lines in the image editor to get a pull-down menu and select Image, Save As. I'll change the file type to TIFF. It doesn't have an alpha channel for transparency, so I'll just go with RGB. Sometimes it's useful to save out at 16-bit for normal maps, and if you feel you can get away with 8-bit, then give it a go and scale it down later. The deflate compression here is fine. I'll just add an underscore n to the end of the name and then press the Save As button. That's all there is to it. Let's take a look at the normal map working in the viewport. Firstly, as we don't need the noise texture, I'll delete that. Then with just the plane selected, I'll go Shift-D to duplicate it and move it off to the side. I'll double click the name in the outliner and rename this to Plane Bake Result. In the shader editor, I'll press the little number 3 at the end of the material name to duplicate it and rename it to material.bakeresult. For the normal map to work correctly, we need a normal map node, so I'll drop that in. We also need the image color space to be non-color. Pretty much the only texture that would be used for color would be anything going into that base color socket of the principal shader. Most of the other maps we might create like metalness or roughness, or of course like this normal map, they're not designed to be looked at directly. Otherwise we may get some results that don't line up with what we baked from in the first place. Once we hook that node up, we should get a decent result in the viewport. To see this in its full glory, I've switched over to Eevee's rendered mode and enabled the light that we had in the default collection. Looking straight on, we can really see the lighting illusion. It really looks like there might actually be lots of geometry on this plane, when of course it's just a texture and some mathematical lighting trickery behind the scenes. Alright, so I'm going to reselect our main bake plane, switch from rendered view back to material preview view. Then I'll switch back over to the cycles rendering engine and then come back over to the bake passes. So we mentioned earlier that we'd come back to the fact that displacement is missing as a pass in the bake type menu. The only way to do this is to use a multi-res modifier. So first we'll enable the bake from multi-res checkbox and we'll notice our options change there. And from the new bake type menu we've got options to either bake normals or displacement. Next, if we come over to the modifiers tab, we can create a multi-resolution modifier. The general idea here is to shrink wrap this geometry onto our underlying brick geometry, and then we'll be able to contain those vertex positions within our multi-res modifier, allowing us to bake them out to the simple plane. So we're going to need a lot more geometry to be able to shrink wrap, and we can use this multi-res modifier to generate it. Each time I press the simple subdivision button, we'll be subdividing our plane, upping our polygonal count by 4 each time. To make this more obvious, I'll turn on the wireframe overlay and then turn off the optimal display checkbox. At around 7 subdivision levels, we're getting a decent amount. We know that 1024 by 1024 means about 1,000,000 pixels, so we're going to need about 1,000,000 faces. Currently our statistics down in the info bar are showing us the total faces of all the objects we can see in the scene. So I'll temporarily turn off the collection that holds all the other objects so that we can just get a clear look at the actual amount of polygons we have here, which is currently only 16,000 faces. So I'll subdivide a few more times until we get to 10 subdivision levels, giving us that golden million faces that we need. Next I'll add the shrink wrap modifier and then re-enable the optimal display so we can't see the wireframe there. Also I'll disable the wireframe visibility globally in the viewport overlays and then re-enable the bake example collection. The next thing I'll do is set the wrap method to project, and then using the eyedropper from the target field I'll select one of the high resolution brick wall meshes behind our bake plane. At first nothing happens because we're only wrapping positively, meaning wrapping to any part of that mesh which is in front of the bake plane. We need to swap that to negative, as all of our geometry is in the negative direction, behind the plane. With that done, we can now see our bake plane wrapping onto that target mesh. There's also an auxiliary target field that we can use to add an additional mesh, so I'll click on the eyedropper again and select the mesh next to the first one we selected. To get the rest, we'll need another shrink wrap modifier, so using the pull down menu to the top right of the shrink wrap modifier that we've already set up, I'll choose to duplicate it. Now we can see that we've got shrinkwrap.001 modifier that we can use. This has the same target meshes as before, so we'll change these in a second. First though, just to see it clearer, I'll use the dots in the top right to click and drag this higher in the modifier stack, though it doesn't really matter what order the shrink wrap modifiers go really. as long as they're below the multi-res modifier. So now we have two shrink wrap modifiers. I'll remove the meshes from one of them and use the eyedropper to select the lower two. This looks like we've got everything we need, though the shrink wrap does now look a bit messed up. To clean this up though, we'll limit the axis along which the shrink wrapping can take place to just the local Z axis on both modifiers. And then that's it. Looking around, that looks like it's done a pretty nice job. We don't need the shrink wrap modifiers anymore though, so from the pull down options, I'll select apply on both modifiers so that all the vertex position data gets pushed into the multi-res modifier. Let's disable the bake example collection now, as we don't need it anymore, and we can get a clear look at our bake plane. For this to work properly, we need to set our level in the viewport down to 0, where we get our simple plane back again. Then, over in the bake panel, we're all set to bake the displacement from our multi-res modifier. We do need an image to bake to though, and the one we already have in the shader editor is for our normal map, which was only 16-bit. So let's create a new image, and because it's for displacement, we should be using a 32-bit image to not get any artifacts like banding. Now I'll click on the little image icon at the top and drag that into the shader editor. Notice the color space is already set to linear, which is what we want. Essentially this is the same as setting it to non-color. At this point, all that's left to do is to click the bake button, which happily renders our bake out pretty quickly in a fraction of a second. Let's move over to our bake result plane and unplug the normal map from it. For this we'll use the cycles displacement. To enable this we'll need a subdivision surface modifier to generate the extra geometry we need to get the displacement. So then we'll set it to simple. The next step is to set cycles to use the experimental feature set. That will give us the adaptive subdivisions checkbox within the modifier that we can then enable. Alright, the next step is for us to drag our image into the shader editor and create a displacement node and hook the image up to the height input, and then the displacement output to the displacement input of the material output. At this point, we can see the result of our bake. However, we're only seeing it as a bump map at the moment. To get the full effect, we need to go to the material settings and change from using a bump only to displacement only. Then all that's left to do is to switch to rendered view, and then we'll see the displacement in all its glory, except isn't that great really. We need more subdivision. So the lower the dicing scale in the modifier, the more finely it chops up the mesh, so giving us more geometry to work with. So taking it down to about 0.2 looks like it gives us enough to show it's working well enough. The only thing left to do for us now is to save it out in the appropriate format. So I'm going to choose OpenEXR for that. The color depth at half is just 16-bit, but we need 32-bit for displacement, as mentioned earlier. So we're going to select the float full there. Feel free to play with the codecs to get the file size down to something manageable. I found that PXR24, even though it's lossy, always gets me great results so far. Then I'll just name it with an underscore suffix that makes sense, for example, underscore H for height or underscore D for displacement, whatever makes sense to you. Taking a look at the file size, we can see that the EXR file is about half the size as the TIFF file in this example. So that should just about shrink wrap us up on the topic of baking in Blender, or at least baking in 2.93 anyway, which is the version I'm using at the moment. Cycles X is a thing now in Blender 3.0, which should make things actually even faster and even simpler to set up. Here I've actually got 2.93 on the left and 3.0 on the right, and we can see that there's a difference between the versions in the sampling section. Currently both versions are set to behave basically in the same way, though in 3.0 we now have options to set a noise threshold, meaning how much noise are we willing to accept in the render, or the bake. Smaller values means less noise, though we can of course just use the checkbox if we wish not to use this feature. Unfortunately for me at the moment, 3.0 seems to be a bit buggy when baking, so I've not been able to properly test this out and compare render time differences, but hopefully once the creases in the code have been ironed out, 3.0 will eventually speed the baking process up pretty nicely. In our example here, having to shrink wrap to get our displacement map is obviously not ideal, especially if you've got hundreds of objects that you want to bake from, as that's a lot of shrink wrap modifiers. So that's one of the reasons we'll be rendering rather than baking, so let's take a look at setting that up. Considering that currently baking within Blender is pretty slow, and the displacement can be a bit arduous, having to set up lots of shrink wrap modifiers, plus seeing how it's a simple 2D orthographic perspective that we're trying to achieve, the easiest way to generate the texture maps that we need would be to render from a camera rather than bake out to a plane. Before we actually generate the texture maps that we'll be using later on as usable assets, we've got a little bit of setup to do. By taking a little time to talk about and set up each pass, such as the base color, the normal, and the height map, and so on, we'll find that at the end it'll be really quick and easy to generate all the maps we need in one go. So let's start with one of the simplest to set up, which is the base color. Firstly, notice here I'm using the overridden linked in meshes, and I've created an extra blend file for this. What we're going to be rendering can loosely be separated into this section on the right, which I'll move into a new collection called facade linked _R, which we can now see pop up in the outliner. And if we click on the checkbox there, we can disable and exclude these meshes from the view, and that should make any navigation within the viewport super smooth now, as well as allowing us to focus a little more on what we'll be working on. These meshes on the inside corner will likely come in useful while we work on both main sections. They sort of overlap and are part of the main wall on the right and the main wall with the missing shelter section on the left. So let's press M to move them into a collection called facade linked _C for corner or center, I suppose. That just leaves this section on the left, which I'll rename with an _L at the end, seeing how it's on the left. I'll press the little checkbox again, so that brings back those central overlapping meshes, and then we're ready to just focus on this section on this wooden facade with the missing shelter. Alright, let's head over to the Render Properties tab of the Properties window. Right near the bottom here is the Color Management. We need to switch from the Filmic default to Standard. By choosing Standard, we're saying we don't want any intelligent and visually appealing scaling of values that we'd get with Filmic in our renders. We need our results to be as predictable as possible. Next, we need to set up the camera. I'll reset its position with Alt-G and its rotation with Alt-R. Then I'll move it out on the Y-axis. Rotate around the X-axis and key in 90 on the numpad there to make it face towards the wall. Let's jump into the camera view with 0 on the numpad, and then press G to move it up towards the center of the wall a little bit more. In the Properties window, let's take a look at the camera settings. When we bake, that's an orthographic render, so we're going to switch that here. We don't want any perspective distortion. Jumping over to the output settings, we can change the aspect ratio of the camera to be square. We can do this by setting the resolution for X and Y to basically the same thing. I'll go with 2048. We can set the percentage beyond 100% if we want. So for example, we can get a 4096 render by keying in 200% here. With that done, let's go over to the orthographic scale in the camera settings and set that to cover a distance that we want to include. Mostly we'll probably be rendering out between the 2 and 4 meters range. Somewhere around 2.5 is fine for now. After lining up the position a little more, I'd like to reduce the amount that we can actually see outside of the camera frame. That can be done with the viewport passepartout 2 setting. So I'll take that pretty high to something like 0.9, if not all the way to black. Sometimes seeing outside the frame can be a little bit distracting. Alright, while we can certainly render some passes from Eevee, the most accurate renders we'll be getting from Cycles. So next I'll switch over to Cycles and choose GPU as the device, as it's usually faster. However, we're going to see in a moment that we'll be instead switching to CPU, as depending on your GPU, you might not be able to squeeze this amount of data into it. Another consideration for our renders is how many samples we'll need. This can be very low, so we'll set it to about 4 for now. Normally the amount of samples would help to reduce the noise in an image caused by, say, the lighting or maybe the depth of field. However, we're not using lighting in these particular bakes, so really the only reason we need our samples is so that the pixel filtering can do its job. And at around 4, that's about as low as we should go for now. Ideally more like 8 or 16 for final renders. Here I've rendered the camera view out with different amounts of samples. This first example is just one sample. To see the differences here, we're really going to need to zoom right in. The area where we're most likely to spot the differences is probably around this pretty high contrast area here. At one sample, it's a little bit jagged looking. Here's the same image rendered with 4 samples. Now I'll toggle between them so that you can get a good feel for the differences there. Next up, I've got the same image but with 8 samples. I think the difference here is getting less noticeable. It is improved with 8 samples, but again this is getting more subtle. I'll toggle between them again to give everyone a chance to catch the slight difference. Next, I've got an image with 16 samples. Again, this is even more subtle. In some images, perhaps this would be more noticeable than it is actually here, but I think we're unlikely to need more than 16. Next, I'll middle click and rotate outside of the camera view so that we can see the render distance. Using 7 on the numpad, I'll take a look from top view and go over to the camera settings to enable the limits in the viewport display section. Using our clip start and end settings, we can see these limits to start just before the geometry we want to render and just after. This should help speed things up a little bit more and also help with any resulting cleanup by not having to render stuff in the background or much further in the foreground than we actually want on our final renders. Between 2.4 and 3 meters looks about right. Next, I'll jump into the shading workspace and give it a second while the vertex colors load. Perhaps the easiest way to get our base color pass would be to simply Control-Shift-Click on our vertex color node. Thanks to the Node Wrangler add-on that we've got enabled, that will automatically hook that up to a temporary emission shader, meaning that if we render now, we won't be affected by any lighting, just the info we need to plug into our base color socket of the principal shader. Though that's not especially convenient having to alter the shader in the shader editor, as we know we'll be needing multiple passes down the line, it'd be better if it was just available as another pass in the compositor. Another option we have in this case is we can simply enable the diffuse color pass. Then if we jump over to the compositing workspace, we can enable the use nodes option at the top, and then on the render layer node, we'll see that there is an output called diffcol. I'll just rearrange these windows a little as we don't need the timeline, so I'll left click and drag from the lower right corner of the compositor window into the timeline to collapse it. And to get the maximum space here, I'll press N to close the sidebar. It'd be handy to have a 3D view to look at here as well, so within the compositor window, I'll left click and drag from the top left to the right to split the view, and I'll change the one on the left to a 3D view, looking through the camera with 0 on the numpad. I can then middle click and drag across the options at the top of the viewport there to slide them across so that we can see the render options and switch over to the material preview viewport mode. We could have just used the shortcut Z for that, but I'd just like to be able to see those there so I can confirm what render mode we're in just at a glance. Let's try rendering from the camera now. To do this, I'll go to the render menu and then choose to render image. We could also just have pressed F12 as the shortcut too, by the way. The first time you render, it might take a while to put everything into memory, but for me, after about a minute and a half, my GPU basically just gives up on me, as we can see from the warning at the bottom in red there that reads, "System is out of GPU and shared host memory." So I'll press escape to close that and then switch from GPU to CPU and try rendering again. After about a minute, we've got what we need. To see the render pass in the window here, we need to switch from composite to view layer and then choose the diffcol pass from the pull down menu. Everything is looking great, but there's a couple of things we might want to improve, and that's this black hole of no data that we have in these sections. It'd be good if rather than being black, that registered as transparent. To do that, let's jump back to the previous window, and in the film settings, let's set that to transparent. While we're testing things and still setting up, I'll reduce down to just 100%, so we're getting a 2K image instead of the 4K image before. Then when pressing F12 to render, it should be a little bit quicker, but also we should see the checkerboard showing up so that we have transparency in our render now. But if we take a look at our diffcol output, it looks like we don't have that transparency anymore. So what we need to do here is to combine our alpha output with the diffcol output. We can do that with the set alpha node. Hooking that up to the composite output should mean that we'll be in the main render the next time we hit F12. We can also get a preview of our changes here in the backdrop of the compositor, though if we Control-Shift-Click on the set alpha node, we'll also create a viewer node and see the image behind our nodes. I like to press V and Alt-V to zoom in and out to this image, and we can clearly see now that we have transparency in our diffcol pass. The thing is, we actually don't want any transparency in our passes. We want to fill in these areas with a pixel value that matches the border of these gaps. This is basically what's happening when we bake. We can actually see we have a margin option with the bake settings. The reason we have this is basically to avoid mip-mapping issues. To give a little more of an idea on what we're talking about here, I've jumped into a super simple cube scene. We can see the lower left, we can see the UVs of our cube in front of the image that we're going to bake onto. Here I'm just using a white emission shader, so I'm going to bake the emit pass, and we're set to 0 pixels in the margin. The bake image is already selected in the shader editor, so I can just press bake to render this out. In edit mode, we can really see the white goes right up to the UV borders, but no further. If we plug this into the emission color socket, we'll then see the result on the cube in the viewport. Zooming right in and making the view a little larger with control space, we can see there is a slight black edge at the borders of some of the UVs. This is a mip mapping issue, and it can sometimes become larger problems when zoomed out. However, for this case, this is probably a very forgiving case. All UVs are perfectly straight and it's a pretty simple bake, but even here we're getting that slight black line. That's what our bake margin is going to be for, to completely fix the problem. We just need to increase to about 2 pixels as a margin here, and then if I unhook the image node from the emission shader so that I can bake again, we can see now the white goes beyond the UV edges, and in the 3D view we've got absolutely no issues whatsoever now in this example. If we want to replicate this within the render, we need to use an in-paint node and drop it in after the set alpha node. So we need our transparency, but only so that the in-paint node can do the work of a margin bleed sort of effect that we would use when baking. As we increase the distance value here, we'll see the same effect that we get from the bake margin, except as a bonus here, if for any reason we wanted to, we can still adjust it after the render. Switching over to just see the alpha channel should show us if we've completely closed the gaps or not, and it looks like there's a little bit left, so I'll take that to 115 where it completely closes up, and then switch back over to see all of the image channels. So that does look good, but if we look closely, we'll see that the values that are being inpainted there are slightly darker. Since this is overall only quite a slight change in value, probably this isn't really going to create any issue for us with mip mapping, but it would be nice to improve and at the very least understand what's going on. So the reason we're getting this darkening here has to do with Blender's pixel filtering that can be found under the film setting. If I change the Blackman-Harris filtering to as low as it'll go at 0.01 pixels, and then press F11 to get our previous render back, we can set ourselves up to use slot 2 so that we can compare the changes easily. Then I'll press F12 to render into that new slot. Pressing 1 and 2 above the QWERTY keyboard allows us to toggle between the render slots really easily. Unfortunately, after the changes made earlier, I don't think I re-rendered, so we'll need to switch over to slot 1 and then change the filter back to 1.5 and then render again with F12. Then, when we use 1 and 2 to switch between the render slots, we can clearly see how much darker the filtered version becomes. This can't really be considered a fix for the problem though, because now we're not getting the benefits of the pixel filtering. The image becomes much more jagged and aliased basically when compared to the filtered version. We'll get far more undesirable artifacts in the image without the filter. To solve this, rather than using the very edge pixel to in-paint with, we'll use the pixel further from the edge. For that we'll use a dilate and erode node on the alpha channel. Setting it to -1 should be all we need to do. However, rather than using this like a mask, we need to simply switch to the replace the alpha option within the set alpha node. Now with a setting of -1, we should get that bake bleed margin we've been looking for without the considerable change in value. Earlier we enabled the diffuse color pass to show up in the render settings. There's actually another option for us to get our base color pass while keeping all of our passes organized within the shader itself. So to wrap up this base color chapter, let's make that change. The first thing we need to do is to add a shader AOV. AOV meaning arbitrary output value. Incidentally, rather than it simply being good for keeping them organized and all grouped in the shader, actually some of the passes are going to demand we use AOVs anyway, as they're not going to be available elsewhere by default. We're going to need the shader editor in a moment, so I'll jump back over to that workspace. And to add a shader AOV, I can just go to the bottom of the View Layer Properties tab of the Properties window, and then click the plus to add an AOV. And then double click on the name to rename it to something more descriptive like base color. And this is a color output, so we can leave it as that. And then all we need to do is add the AOV output within the shader editor. And now we can hook what we've got going into our main shader, also into the AOV color input. Finally, we just need to give this a name to tell Blender which AOV we're talking about. It's fairly easy at the moment as we only have one, but here we would write it exactly as we wrote it in the properties window. So base color with a capital B and C. Switching over to the compositor workspace, we'll see the base color AOV show up in the render layer node. So we can now hook that up to the set alpha node instead of the diff call pass. We haven't rendered it yet, which is why it's still black. Then going to the render layers, we can disable the color pass of the diffuse section as we no longer need it. That's just basically a duplication of our AOV that we've just set up, except for having to save it out manually. This is no big deal for just one pass, however, for multiple passes, it's got to be nice for them all to save automatically, and for this we can use a file output node in the compositor. So let's go Shift A to add in a file output node and hook it up. With the node selected, we can press N to open the sidebar and take a look at the properties. This is where we can choose the file type we want to save as, which for base color will be TIFF. We'll not be saving the alpha channel, so just RGB is fine, and we don't need any more than 8-bit for the base color either. The name of the file I'll call base color, though typically we'd want to call it something like wood facade _ BC perhaps. Taking a look at the node itself, we can see on it the name of what the file will be and the file type. Another general workflow tip is that it's usually a pretty good idea to mute these output nodes with the M key right up until the moment you're actually going to render. Just in case you're changing something in the scene, hit render to see the results and forget that the file output node is unmuted, as we'll actually be saving that file to disk, or in fact overwrite an existing file we might have wanted to keep. Finally, let's do a test render. I'll give us a bit more room by closing the sidebar with the M key. I'll unmute the file output with the M key, and then click on the little folder icon to set the folder. I'll use the same folder as these other test renders. Then when we press F12 to render, we'll wait for that spirally goodness to unfurl, and then we no longer need to then save the file manually. The file output node will do that for us automatically. So we can just double check that by clicking on the folder icon again, and we'll see there's our new image base color 0007.tiff. The reason for that 7 is because we're on frame 7, which we can see up in the top left of the 3D view. So to go back to frame 1, we can just shift and left arrow. The next time we render, we'll have a 000 and then a 1 instead. So that wraps us up here for the base color. In the next chapter, we'll see how learning how to set the AOV up helps us, as we'll add a normal map as an additional render pass, and then beyond that we'll add more passes that we'll be able to then use as a kind of template for future renders. In order to add the nodes we need for the normal map pass, we need to continue with the material we left off with after setting up for the base color. First though, just to keep things a little organized in the compositor, I'm going to select the 3 nodes doing the margin bleed for our base color, and then press Shift P to add them to a frame. Then I'll press F2 to name this to base color. Then I'll just do a little reorganizing here and also add the file output node into that frame too. Just by dropping it in, it should be automatically added to the frame. Next I'll jump over to the shading workspace to start setting up the normal map pass. This would all be very easy if we could just add a vector bump map node, and the normal output that we got from it was equivalent to that of a tangent space normal map output. Unfortunately it isn't, as we'll see if we use Ctrl Shift to click on it. Thanks to the Node Wrangler add-on that we've got enabled, we can see that hooked up to an emission shader for us so that we can visualize that in our viewport now. These definitely aren't the sort of colours we'd expect from a tangent-based normal map. Jumping into the camera with 0 on the numpad, I'll then change to solid shading mode and then switch to matcap mode. As we can see, the sorts of colours that we do want should be like the ones we can see with our normal matcap. It's not especially clear in the viewport though, as we're also seeing this mixed in with our vertex colours, so I'll switch over to the material option, and then in the material settings we just want to make sure that the colour in the viewport display is actually fully white and not slightly off-white, as you can see here. So I'll just nudge that up so that what we're seeing in the viewport isn't getting tinted or darkened at all. Next I'll clean up the view by turning off the overlays and all the outlines in the viewport shading menu. Looking at the result of our normal output now in context compared to the matcap, we can see we need to do a little work to bring these together. The first thing I'll add is a vector transform node, switch this to normal, and then transform our vector coordinates from the world, as they are by default, to the camera. This means that now the normals will follow and stick to the camera as we move and rotate around the scene. This is the same way as a matcap would work. To make it easier to understand what's happening in the viewport, I'm going to create an icosphere in the original collection. I'll make it more spherical by giving it more geometry, by setting the subdivision level up a bit. Then right click on it and shade smooth, so that it doesn't look all faceted. Next I'll give this helper sphere object the same material as everything else, and now hopefully it's even clearer that now the normals are tracking to the camera. The bottom right side of the sphere stays on the bottom right side of the sphere no matter where we orient ourselves in the scene. If we mute the vector transform node with the M key, you can see the normals colours align with the world. And as we move the camera, we can see that we can reveal new colours such as green behind the sphere. With the vector transform node unmuted with the M key though, we're always going to get consistent colours depending on the camera. This means it doesn't matter which wall we're looking at, which orientation the camera is, we should still get the colours we need for our normal map to be correct, which is what we're going to set up now. So I'll press 0 on the numpad and select our reference sphere, that will be helping us out here, and scale and move it so that we can see it clearly. The next thing we'll be wanting to do is go to add a converter, separate XYZ node so that we can split the channels. We'll also be wanting to combine them back together again, so we'll also need our combined XYZ node. The X and Y channels are fine, but the Z will be wanting to flip, so that's what we'll do. Control-Shift clicking on the node once will give us the X output in the 3D view. This is what we would expect. The X-axis should be running from left to right. Control-Shift clicking again shows the Y-axis output, and again that looks correct as it's running from bottom to top. The Z-axis is only showing us black though, when we would be expecting white here. So as we mentioned, the X and Y are fine, so we'll plug those into the combine node. But for the Z-axis, we'll need an invert node, which I'll then hook up. I'm adding this invert node here for demonstration purposes while we set this up. I just think it's going to make more sense explaining it in this order. However, a little later on, I'm actually going to put the invert node after the other nodes we'll be adding in a moment. Control-Shift clicking on this will show us that everything looks white now, which isn't surprising, but it isn't exactly what we want. We still want to see a gradient of values from dark on the faces that are most turned away from the camera to bright where the faces are basically just looking straight at the camera. To show that these values are there, we can use a math node to offset the values. We don't need to do this just here though, this is just to demonstrate that our gradient of values are really there. So I'll just go Control-X to delete that node while maintaining the connections through it. And we'll do remapping of the values using 2 color mix nodes, as we want to affect all the channels at the same time, now that we've flipped our Z-axis. If we look again at the X-axis, we can see that the sphere looks black in the center, and then goes to white at the right edge of the sphere. Currently what we've got is actually -1 on the far left of the sphere, but as our monitor is clamped at 0, we can only see black. In the center is 0, which again is black. And on the right side it's 1, which shows on our monitor as white. Values above 1 are just going to be similarly clamped and just show as white though. But we're only looking for values between 0 and 1 anyway, for a tangent space normal map. So simply put, we need to remap going from -1 on the left to +1 on the right to go from 0 on the left to 1 on the right. To do that, we'll change the color mix type to add, and then make the second color swatch pure white, or in other words a value of 1. So -1 on the left, after we add 1, will become 0, which is what we want. And what was 1 after adding 1 becomes 2, which is not what we want, which is why we need our second color mix node. So at this point we've got values going from 0 to 2, and instead we want it to just go 0 to 1. So here we just need to multiply by 0.5, which it looks like the values of RGB actually already are set to in this node. So 2, which we've got on the right of the sphere, multiplied by 0.5 becomes 1. And that should just about be all we need to do. Control-Shift clicking on the final node in the sequence reveals that our output now looks like a tangent space normal map. Though, if we look at the matcap again, we can see the colours look quite a bit darker. This is because most normal maps that we're used to seeing aren't actually being presented in linear space, which is what we've got with our nodes at the moment. To convert this though, so that they do look practically identical, all we need to do is add a gamma node set to 2.2, and this will rescale our values so that we get a normal map output that we might be more familiar with looking at. Switching between the solid shading matcap and the material preview of the nodes, we should see that they much more closely resemble each other now. We can see on the bottom right we have a reddish hue, red is representing our X direction, and on the top we have a greenish hue, with green representing our Y-axis. However, the values aren't quite right, only pretty close. This is because of where in the node chain that we're doing our inverting. Earlier I mentioned that I'd moved the position of the invert node after we'd explain more, and it's at this point we can now move the nodes handling inversion to where they need to be, which is after we've now remapped our values from 0 to 1. So I'll select these nodes here and press Alt-D to disconnect them, and then move them out of the way for a second, and now we can slot them back in just before the gamma node, and then hook them up, adding the inversion to just the Z-axis for now. It's at this point if we switch between the matcap in solid shading view and the results of our nodes here in the material preview, we'll see that the results are practically identical. In some applications, you'll notice that the green hues we're getting here at the top are actually on the bottom. In that case, we just need to flip the green channel, that is to say the Y-axis. For completeness, we'll give ourselves the option to flip the red channel too. This is all very reminiscent of the sort of options you'd find in the baking panel. So with that done, I'll just select all the nodes and press G to move them off to the left side. And also we don't need our demo sphere anymore, so I'll just turn off the visibility. Now that we have the shader sorted out, all we need to do is to add the actual pass to the compositor. So I'll go over to the View Layers tab of the Properties window and go all the way down to where we can click the plus to add another AOV. I'll double click this and name it to normal. This is also a color type, so we can leave that as it is. Then I'll jump into the shader editor and add the AOV output set to normal and plug our normal map related nodes in. With that done, we can Control-Shift-Click on the main principled BSDF shader to hook that back up, as we don't need to see our render passes in the viewport in order for us to render them out. Over in the compositor workspace, I'll copy the previous nodes with Shift-D and move them down. This way we'll still get the in-painting in the same way as we did for the base color. We just need to make sure we hook up our normal map output and alpha output into where they should be. For the file output node, I'll select it and then press N to open the properties sidebar and then name this normal. Eventually we'd want to change this to a better name like wooden facade underscore N or something like that, but for now this is nice and descriptive. The other settings for this, such as it being in the TIFF format and RGB, are fine, though for the normal map I think I'd like to save as 16-bit. In a lot of cases we can get away with 8-bit though, and might actually need to use 8-bit depending on the 3D engine you'll be putting the resulting images into, so this is something to keep in mind for normal maps. Again, I'm happy with the 16-bit here, so that's what I'm going to leave it as in our case. But that's about it. All I'll do now is unmute that file output node with the M key so that we're ready to render and write that resulting file out. Here I almost forgot, but I'm going to rename the frame with F2 to normal. Also Control-Shift-Click the main render layer node so that we hook up the view node to the main image output, as well as hooking up the composite node and moving things around so it looks slightly more organized. Actually, these little reroute nodes I didn't add to the frames, so I'll just need to select them, move them slightly, and then let go for them to be added to the frames that they're already on top of. Similarly, I'll do a little organization in the shader editor by dragging across the two groups of nodes we've got there, and then going Shift-P to add the frame, and then F2 to name them accordingly. With that done, all we need to do is render out whatever passes we like by making sure that file output is unmuted, and then it will render and write them all in one go. For now, we're just rendering this one normal map output to make sure everything's working correctly though. Once the render is complete, we can switch to the view layer in the image editor and see the passes all look good. The transparent areas there, of course, we have filled in with the in-paint node within the compositor. Taking a look in the file browser and changing to thumbnail view, we can see we've now got our normal map in there as expected. So that should wrap us up on this chapter, and we'll develop the idea further by adding in further passes next, most crucially our height map. To get our height pass is actually pretty simple. We can actually get it in numerous ways, but the way we'll get it here is by using our texture coordinates. Then if we take a separate XYZ node and plug our object coordinates into it, that's pretty much it. We can Control Shift and click on the Separate XYZ node so that we can see just what the X-axis is doing. Thankfully, because we've got our Node Wrangler add-on enabled, it's quick and easy to see what any given node is doing. And we can Control Shift click again to toggle through the outputs of the node so that we can see how the Y and Z axis look as well. It looks like it's the X-axis that we want though. The closer the geometry is to the camera, the brighter it should be, which is why we can see that it gets darker the further away the geometry is from the camera. To explore this a bit more, we can use a math node to offset where the 0 position is, though I don't find this a very visually satisfying or instructive way of fine-tuning our height map. Instead, I think it's much better to use another object, such as a cube. We've actually got a cube in the outliner currently hidden. To get all the controls we need to show this cube again though, I'll click on the filter and choose to see also the toggles for enabling each object in the viewport, as well as the option for toggling the selectability too. Now I can enable that cube to show again in the viewport. Next, I'll select one of the scans again, and in the texture coordinates node, select the cube from the pull down. Now we can see the center of the cube now controls the position of the 0 point in our height map. Though it looks like we're using the wrong axis for this, so I'll use the Y-axis instead. In fact, we don't need that math node, so I'll delete it using Control X so that we still keep the wire going through where the math node was. While the Y-axis is correct, it looks like it's back to front, so the closer the geometry is to the camera, the darker it is. To flip this, I'll just rotate the cube around by pressing R and then Z, and then keying in 180. Notice that if we move the cube on the Z or X axes, then we won't affect our height map. It's only the Y axis that is important to us. Double tapping R to get into trackball rotation, you can see that the coordinates are affected though the geometry is pretty well lined up with the camera already, so I think we can cancel any other additional rotation for the moment. I like using this cube because the front face of the cube represents where values on the height map will be 1, and the rear face will show where the values will be -1. It's not crucial to know that information, but it just helps keep everything predictable should you get any unexpected results down the line. One downside of using this cube at the moment though is that it's kind of getting in the way. Something that wouldn't be a problem if we were using, for example, an empty. We can get around this nicely though by just using a wireframe modifier, and now we can see through it. Or at least partially at the moment anyway. There's more geometry there than I was expecting. Let's clean this up a bit. With the cube selected, I'll press slash on the numpad to just isolate it for a moment, then tap into edit mode, select everything with A, and then press X for a limited dissolve. That should get rid of all geometry that I wasn't expecting. Tapping back into object mode, everything is looking way clearer with that now. Next, I'll press slash again on the numpad to exit our local view, and then I'll open up the sidebar with the N key. Our modifier is actually adjusting the actual dimensions of our cube, which I didn't really want. I actually wanted to keep that cube at a perfect representation of where the value of the height map would be 1 and -1, as mentioned earlier. It's easy to adjust this though. I'll just change the offset down to -1 so that the additional geometry for the wireframe is being extruded inwards rather than using our original geometry as sort of a midpoint. Checking the dimensions now, and we can see that we're back at 2. Next, I'll make this clearer in all lighting conditions by deleting the principal shader and using an emission shader instead, set to some vibrant color. In case we want to see this same color in solid shading mode, I'll also click and drag the color we've just set down into the viewport display color for the material as well. Over in rendered mode though, there is a slight issue with using an emission shader of course, which is that it's emitting light into the scene. This is more obvious if we crank the strength right up. One option we have to get around that is to simply go over to the Object Properties Ray Visibility settings and make it only visible to the camera. With that done, we can switch back to Material Preview so that the viewport's a bit more fluid, and select one of our scan objects and complete setting up the shader by hooking it up to an AOV output. First of all, let's create an AOV by going over to the Render Layer Properties tab, and down at the bottom click the little plus icon. Double click the name to rename it to height, and then this is just a single value rather than an RGB output, so I'll switch that here. Then in the shader editor, we just need to create the AOV output node and label it height, and then hook it up. I've made a mistake here though, which I'll correct in a moment. I should have hooked that up to the value input instead of the color input, as we've just switched it from color to input in the AOV settings. For now though, I'll continue setting up by right-clicking and dragging across the wire so that we can Control-Shift-Click that reroute node to instantly see the y-axis rather than having to cycle through the x-axis first. Next, I'll create a frame for these nodes with Shift-P and then F2 to name it to height. Over in the Compositing tab, I can now use Shift-D to duplicate the nodes we need for the in-painting, or our edge margin in other words, and then rename that to height, and then hook up the height output from the render node and also the alpha output. It's getting a little messy there though, so I'll try to clean it up a bit by using some reroute nodes for the alpha channel wires. One last thing here in the compositing workspace is to select the file output node and press N to open up the sidebar so that we can adjust the settings there. I'll rename it to height, change from TIFF to OpenEXR so that we can get those negative values saved in the file, and switch to the full float for 32-bit rather than 16-bit. And I've found that many of the lossy codecs, such as PXR24, work great to reduce the file size while keeping all the info we need. What I'll do next is to mute the output nodes for now until we want to render. First I'll head back over to the shading workspace so that we can decide where exactly to place our cube. That is to say the 0 point of our value range. I'll use this icon to pin our material here, that way we can click around between objects with different materials but still be able to see this main one here. When trying to decide where to place that 0 point, I'm just thinking I'd like to be able to still visually make out what we're looking at, but get as close to the main wall center as possible. It's actually tricky to see with the current cube exactly where the midpoint is. So what I'll do is make some adjustments to the geometry of the cube. So I'll tab into edit mode and isolate it into a local view with slash on the numpad. Then I'll go Control R to create an edge loop that goes around the middle like this. Then I'll need to left click to confirm that and then right click to avoid sliding that new loop. What I'd like to do is have a face inside the cube that can represent that central plane. So I'll do this in wireframe view by pressing Z. Then I'll press 2 for edge select mode and then alt left click that loop to select it. Then I'll press F to create that internal face. Then I'll press Y to split that face so that it's not actually connected to the other edges anymore. Then I'll right click and subdivide this a bunch of times until I get a reasonable grid of faces there. Now tabbing back out into object mode, our wireframe modifier will spring back into life. To see this properly, let's press Z to jump back to material preview mode and then slash on the numpad to exit our local view, and then we can see everything in context. Let's bring the cube forward a bit so that the central grid is more in line with the wall geometry, which looks to be about there. And so that it's not all plunged in black, I'll just push it back a little bit. We don't really need to do that, but it'll just mean it's a little bit more readable here in the thumbnail and if we were to be adjusting it in something like Critter or GIMP. This cube has been pretty faithful and helpful for us, so let's promote it by giving it a name. To do that, I'll double click it in the outliner and call it Height Map Helper. And we can see there it's not set to render, as it's just helping us out behind the scenes and not required for the main render, of course. Then we're almost ready. We can head over to the compositing workspace and unmute the height map output node, and then finally correct the mistake I made earlier by using the value input, not the color input of the AOV height output node. And that's it, we're done. We can now render with F12 and wait for the render to complete. Once it's done, switching from composite to view layer shows we've got the 3 render passes there now, the base color, the normal, and the height. Clicking on the little folder icon at the end of the material output node, we can see there's our height map automatically saved out for us. To conclude the chapter here, let's just bring it into the scene and compare it with our scan data, just to check the mid-level and scale are all correct. Over in the shading workspace, I'll use the little image editor window we have in the bottom left to click on the open button, and then I'll double click the height map we've just made, and then I'll make a new plane that we can put this on. I'll hit slash on the numpad to keep this isolated for now, and then unpin our other material and create a new one, which I'll call height demo. For the displacement, we need to set up a few things. First of all, we need a displacement node hooked up to the material output, and then I can click and drag the image icon to the left of the name in the image editor into the shader editor and hook that into the height input. It's an EXR file, so Blender knows to set the color space in this node to linear, which is what we want. Next, let's set up the subdivision surface modifier and set it to simple. Then we'll need to set the feature set to experimental, so that when we return back to the modifier, we have a new setting that we can enable called adaptive subdivision. Finally, in the material settings, I'll switch from bump only to displacement only. Now when we switch to rendered mode, we'll actually get some displaced geometry. Although it's a bit tricky to see here, so I'll jump back out of local view with slash on the numpad, wait for a few seconds while everything loads in, and I'll start by orienting this plane like the wall is by pressing R to rotate, and then X, and then 90. It's a little dark still, so I'll try moving the lamp, but it's a bit sluggish in the view while it's rendering all of this, so I'll switch over to material preview for a moment and move the lamp so that it's somewhere in front of the plane. To line this up, I'll select the camera and then go Shift S to snap the cursor to the selected object, and then select the plane and go Shift S to snap the plane to the cursor. Now I can just move it along the y-axis to get it nearer to where it should be. In fact, 0 on Y is pretty close. We'll get it exact in a moment. First, looking from the camera view with 0 on the numpad, we can see that the plane is a little smaller than the camera frame of what we've rendered, so we need to scale up our plane. To find out exactly how much to scale by, we just need to select the camera, which I'll do by clicking on the border in the 3D view, and then in the camera data properties, we can see it's an orthographic scale of 2.514, which I'll just select and go Ctrl C to copy it. But we can just hover over that value and go Ctrl C if we like. Then I'll select the plane in the outliner and then click and drag across the X and Y axes and paste our value in with Ctrl V. Our plane should now perfectly match the frame size now. Next, let's take a look in rendered mode. We can see that the displaced geometry is a little bit behind where the real scan data is. To properly align it, we'll need to copy the y-axis setting of the helper cube. So I'll select it, go Ctrl C on the value, select the plane, and then go Ctrl V on the y-axis there. It's still not quite in the right place yet, but just before we make the final correction there, I'll select one of the main scan meshes and Ctrl-Shift-Click on the principled shader so that we'll be able to better see between the scan data object and our plane object, which has this displacement. Then I'll select the plane again in the outliner, and then all we need to do is go to our displacement node and make sure that our mid-level is at 0. At this point, it should look almost perfect. We can make it even more perfect if we apply the scale that we made when we altered the dimensions of the plane, which we can simply do with Ctrl A. From there, we can give the displacement a bit more resolution by lowering how finely we're dicing it all up. So I'll take it to 0.5 here. At this point, we should see it's a super close match, so we know we've got our scale and mid-levels all working perfectly. Just to see this a little clearer, I'll move the plane off to the side, right-click it to shade it smooth, and we should be able to compare it with the scan data side by side to confirm it really is a good height match. To finish off, I'll click and drag across the visibility and renderability icons in the outliner, and then switch over to material preview, select one of the scanned meshes, and just center the node frames a little bit more, but that's it. At this point, we're able to render out at least 3 passes in one go pretty easily.